All right, I'm back. So we are in our notes packet. Again, if you need one of these because you forgot it at home, just ask your substitute for that. And where we are going to be is in section, if I can get to it, the second section. Oops, I should probably start this video over because I'm not even close to being in the right spot. Hold on, humor me. We're going to be on page 8. And so we're going to go about this not necessarily in the order, but I'm going to be making 3 short videos instead of a longer video. So our first part of the video, again, I'm on page 8. We're going to be talking about the 3 forms of quadratic functions. This is review from Algebra 1. All the things I'm about to show you, you learned in Algebra 1. So there is this expectation, as I'm sharing the notes with you, that you know how to do this. So the first thing I want to talk about are the 3 forms of quadratic. So there is vertex form. Vertex form has that parentheses squared. This is the form that you used to graph in the previous section and the notes. And then you got standard form, and instead of f of x, I'm just going to use y. And this is it. Y equals ax squared plus bx plus c. And then you have factored form. Sometimes it's also called intercept form. And it looks like this. So it's an a. And then in parentheses, they have x minus p. And I do not make up these letters. This is what they use, an x minus q. What you want to notice is that they all have x and y, whether y is y or f of x. And they also have an a. And remember, a is that stretch or compress factor. And back in Algebra 1, you worked with all 3 forms because all 3 forms would help you find a key point to your graph. And you can make your parabola shape just by looking at each form. And so what a vertex form tells you is your vertex of your parabola. And that was vocabulary mentioned in the 2.1 graphing video. And the vertex is when you go into the house and you have an x and y coordinate, and the x coordinate is just the opposite of h. So I'm going to abbreviate opposite of h. And then your y-coordinate of your vertex is just your k value, and that's k as it is. So just by looking at it, I can be like, oh, there's the vertex. It's this and this. Standard form tells you the y-intercept. And what all y-intercepts have in common is that your x value is 0. And just by looking at this, without any math, I can see the y-intercept. Because if I do put 0 in for x, and I follow my order of operations, 0 squared is 0, 0 times a is 0. So this term turns to 0. And then if I put 0 in for here, 0 times whatever this number might be is still 0. So I would end up with 0 plus 0. Basically, these 2 terms go away, and I would just be left with the c value. And so I can just see the y-intercept. And then factored form will tell you the x-intercepts, and we'll worry a little bit more about that later. Okay, so again, all 3 forms tell you something. So this is a map that you probably saw your freshman year. And what we're going to talk about today are how do you, follow these different paths. So what we're going to start with is how do you go from factored form to standard form, and how do you go from vertex form to standard form. All right? And so that means we're going to skip this section right now, not forever. And we're going to jump to page 9, and we're going to go to this part, this bottom part, and we're going to walk through these 4 problems. So how do we go from factored form or vertex form to standard form? And basically, it's just a lot of multiplying. And then combining like terms. Combining like terms. I'm going to abbreviate that. So where we're going to start is this one down here. And what I call this is the neighbors meeting the neighbors. So what I want you to imagine is, we have 3 neighbors here, 2, x plus 1, x minus 3. In this problem, we have 2 neighbors, 4x and x minus 2. And they're really close next door to each other. They're like an apartment. They share a wall. And so my thought is the neighbors have to meet the neighbors. You have to like each other's. Okay, I had to pause there for a moment because that was just starting to sound stupid. So anyway, the neighbors meeting the neighbors, it's a shortcut for multiplying. So if you're right next door to somebody, you better like them. So you need to go and meet the neighbors. So this is my version of the distributive property. Distributive property, maybe you learn some shortcuts like FOIL, first, outside, inside, last, and that works for only certain problems. But my little trick of the neighbors meeting the neighbors works for all of them. So we're going to start with this one, and 4x lives in one apartment, and x minus 2 lives in another apartment, and so they better like each other because they're right next door. So 4x is going to go over and meet x and the minus 2. And again, this is just multiplying, and I get 4x squared minus 8x. And that's it. It's multiplying. So neighbors meet the neighbors. Now up here, again, I told you there were 3 neighbors, 2, x plus 1, and x minus 3. And when neighbors meet, you can only have one set meet one set. So when you have 3 sets of neighbors, the neighbors I would recommend that you have meet first, or where you're multiplying takes first, are the ones with parentheses. So x decides to go over and meet the neighbors. And I'm just going to put this over here. So when x meets x, I get x squared, not 2x. X plus x is 2x. X times x is x squared. And then when x meets this minus 3, I get minus 3x. And now that x has met the neighbors, now 1 is going to go over and meet the neighbors. And so when I do this, I get 1x, and I will be combining it with this minus 3x, so I'm going to stack my like terms. And then when 1 meets minus 3, I get a minus 3. And then I'll just add them up. And now they're this new group. But there's still one other neighbor that needs to go meet everyone, and it's the 2. So now the 2 is going to come over here and meet all the neighbors. And I would really suggest you draw these loops. I think it helps. So 2 meets x squared, and we get 2x squared. 2 with the minus 2x is minus 4x. 2 with the minus 3 is minus 6. So again, neighbors meeting the neighbors. These 2 problems were in factored form, and we just did multiplying distributive property of some form to get them in standard form. These problems are in vertex form. Remember, they're both going to have parentheses, but vertex form has the parentheses squared. And what the squared means is that there's actually 2 of these x plus 2's. And again, we got some neighbors who need to meet each other. So x plus 2 needs to meet x plus 2. They're right next to each other. This minus 3 that you see here is a little bit further off, so not part of the neighbor situation. So x is going to go meet everybody first, and we get x squared and 2x. And then 2 is going to go meet the neighbors, and I get another 2x and a 4. I'm just multiplying. And then I'm going to add these up. And now all the neighbors have met. This minus 3 is going to come back into the problem, and now I'll just combine these like terms of 4 minus 3. And when we're done, we get that. Okay? Excuse me. All right. Next one. So we have negative 2. We have 2 of these x minus 3's. And then we have the plus 5. So here, everyone's crowded together. These are where the neighbors need to meet the neighbors. And again, when you have 3 neighbors, here's 1, here's 2, here's 3. We're going to start with the ones in parentheses. You don't have to, but that's what I usually do. So x is going to meet x and the minus 3, so I get x squared minus 3x. And now this minus 3 is going to go meet everybody. And negative 3 with negative 3 is a positive 9. I'm going to run out of room here. I'm going to add those up. And then I got to remember there's still, whoops, sorry, you couldn't see that, that there's still this neighbor of negative 2 who needs to meet everybody. So I'm going to move over here. Now I have negative 2x squared. I'm going to have a 12x. And I'm going to have a negative 18. And then I don't want to forget about this plus 5. And now I'll just combine these like terms, and when I'm done, I've got negative 2x squared plus 12x and negative 13. A great way to check to see if your answer is correct, and I didn't bring my calculator down, but go to the y equals button, type in the original equation in one of the y's, type your answer in the other y, and then when you hit zoom 6 to graph, you should only see one graph, because these are actually the same things. They're called equivalent forms. This is the vertex form. This is the standard form of the same function. All right? So what I'd like for you to do now is to pause for a moment, not finish the videos, because there's going to be a whole new video, and I want you to go to page, let's see, 12, and spend, pick 2 problems here to do. Any 2, I don't care, and then show your answers to the substitute, and he's going to check that off, and then you're going to go and resume the other videos. Real quick on this one, this negative, maybe you want to see this as a -1 with 2x plus 5s, and then your plus 1. And again, when you have the neighbors meet here, I would start with the parentheses and then have the -1 meet them. All right.